Moving on to solving the problem, I wrote down 5 steps that to guide you when solving the problem. This also helps to systematically solve the problem and not to miss out any time or find yourself whereby you end up having too many unknowns and being unable to solve the problem. So as usual, the first step is to draw the BFD and perform mass balance calculations so that you can reduce the number of unknowns. After performing mass balance calculations, you'll find out that the only unknowns will be the average composition and also the composition of the liquid inside the column, which are the requirements of this equation. So the second step is to find 1 over y minus x. You simply just subtract the y values with the x values, which are the xy data given on the problem statement, and then you'll have them like this here on a table, so you can extend your table. And then the third step is to plot this 1 over y minus x versus x on your graph, whereby now you'll find the area under the graph to determine your x2. You'll see later on when we continue solving the problem. So step 4, we're gonna use Relay's equation, the Simpson's rule, and the graph to determine x2. And I say that this is an iterative process because the only way to solve it is through iterative means, by initially guessing a value and then trying to compare it. If the initial guess is not correct, you guess a different one and onwards like that. But you also see when we go deeper into the question. So, and then the final step now is to find y average using this equation. It's given differently on your notes, but I showed where it came from, and you'll see later on as we continue with the problem. So now moving on to the solution, this will be your BFD before you've labeled any of the terms that you have calculated. So this is F or L1 in case if it's not clear enough. So the L2 it will be the amount of liquid left inside the column, and X2 will be the composition. And then the y average is the vapor composition, the average vapor composition that you've been collecting. So drawing a BFD like this also helps you to understand when going back to Relay's equation that which terms are which, because a general mistake that you can make is to put x2 here, and this will add some confusion on your calculations, because now you will have x2 and y average at the same place. So drawing it like this, this is the general structure, so you can use on all distillation on all batch distillation columns when trying to solve them. So after drawing the structure, we perform the mass balance calculations. I wrote the general mass balance equation just to add extra understanding on the problem. So we have input plus generation equals to output plus accumulation plus consumption. The generation term, as you know from fundamental, it's for reaction processes. So this is where you'll put your product. So in this case, there's no reaction, so it's 0. Output, it's the output. Accumulation is the liquid which has been accumulated, as it will end up being L2. Generally, when you solve problems, you usually don't have accumulation, but for batch systems which are not steady state, they always have accumulation. And consumption is for reaction processes. This is where you put the reactants which are being consumed. So after cancelling out all the the terms that are not involved in our balance equation, we end up with this equation. And then we know from our BFD, our input, it's L1 here, and our output, it's V2, and our accumulation, it's L2. And then you can solve and find L2. Once you've done this, you can move to step 3, which is to plot the this 1 over y minus x versus x. In this case, you will see the graph later on when we try to solve the problem. So after step 3, we can move to step 4, which is the more crucial one, yeah, for the problem.